Good morning, student. I am Dr. P.S. Kaushik, Principal at Sri Digambar Institute of Technology, Dosa, Rajasthan. I am taking the subject engineering mechanics. This subject belongs to civil and mechanical engineering in third semester. This is my 11th lecture. Let us see what we learnt in the last lecture. In the last two lectures, that is 9 lecture and 10 lecture, we learnt about the moment, principle of moment, then Varegran thumb, beam, type of supports, types of loads and problems based on above. We solved around 10 to 12 problems. Now, what is moment? We told that when we apply a force at one end of a beam or lever, keeping other end hinged at or fixed at other end, then there will be a turning effect of that force. About the point this lever turns is called moment center, and that lever length is called moment arm. That moment can be a twisting moment or a bending moment. Its unit is Newton meter. Then we learnt about the principle of moment, that is when body is acted upon by number of forces, then the sum of the clockwise moment will be equal to the sum of the anti-clockwise moments of the forces if body is in static equilibrium. Then we learnt about the Varegnan thumb, which states that if a body is acted upon by a number of forces, then sum of the moments of these forces will be equal to the moment of their resultant about the same moment center. Then we learnt about the beam. Beam is structural member which is kept horizontally on supports and it is loaded across its length, that is vertical to the loads are usually applied vertical to the length of the beam. There are two types of stress is generated, that is bending moment is generated and the shear stress is generated, and we make calculations for shear force and bending moments, and we draw diagrams based on shear force and based on bending moment. Since the bending moment and shear force both vary along the length of the beam depending upon type of load and application of the load. That type of load and point of application of the load. So, the shear force will vary, and the depiction of shear force on a beam in graphical form is called shear force diagram. Similarly, the depiction of the bending moment across the length of the beam will be called as bending moment diagram. This is not in the syllabus for civil engineering, but it is for mechanical engineering. We will be taking this class exclusively for mechanical branch. Then we learnt about the supports, that is hinge support, fixed support and roller support. Three types of supports are there. The types of load. Any type of loading can be easily visualized in three types, that is point load, uniformly distributed load and the uniformly varying load. So, any type of load you apply on a in random, that load can be visualized into three type of loading that we classified, I can say, into three type of load, that is point load, then uniformly distributed load and uniformly varying load. We solved 10 to 12 problems based on principle of moment and Varegnan thumb and found out the reaction rate supports and other problems. Now, we are changing the topic, that is friction. What is friction? That is refer to the figure 1, that is when we apply a force to move a block kept on a surface, rough surface, weighing W kg to the right with the application of a force P, a resistive force is generated between the two surfaces, block and the floor. This resistive force is called friction force, or simply we call it friction. When the body is just to move, that is impending condition of motion, the conditions of static equilibrium state that P is equal to F and R equal to W. R is the reaction, W is the weight, P is the applied force horizontally along the ground, then mu is the coefficient of friction, and there is a relation between F and R, F upon R equal to mu where mu is called the coefficient of friction. It is a ratio between the force and the normal reaction, hence a unit less quantity. Now refer to figure 2. The force P applied upward making an angle theta with the surface which is horizontal, again at impending conditions of motion, F equal to P cos theta and R equal to W minus P sin theta. Friction in engineering is very essential as well as very undesirable also, depending upon the application. The friction is undesirable in case of bearing, gears and power screws. Here we do not want friction, because friction the power is consumed in the and get dissipated in the form of heat by the lubricant we are using for bearings, gears and power screws, and there will be a less efficiency if there is more friction. But friction is highly desirable in case of brakes, clutches, belt and rope drive. If there is no friction, there will not be, you will not be able to stop the vehicle, and you will not be able to engage the power of engine to the transmission system, that is differential mechanism, if there is no clutch, or there is less friction in the clutch. The belt and rope drive, again there is importance of friction here. We will be using this, we will be dealing these topics in the coming lectures. Hence, it can be concluded that friction is a necessary evil. Now, refer to the figure 3rd. Say, yes, that is 3rd figure. Here, a force applied is inclined at an angle theta downward from the horizontal. Again, at the impending conditions, under the conditions of static equilibrium, F is equal to P cos theta and R equal to W plus P sin theta. The characteristics of frictional force. The frictional force is passive in nature. It is proportional to the inline force component of the applied force. It depends upon the nature of surface. It is independent of shape of the surface. It is independent on the area of the surface. Now, let us just try to learn more about the characteristics. Frictional force is passive. It means it get into action only when the external force is applied. If the external force, and it is always proportional to the force applied, it will go on increasing proportional to the applied force until the impending condition is reached, and at the impending condition, just when we apply more force, then the body starts moving. It depends upon the nature of force. If surface is rough, the friction will be more. If surface is less rough, friction will be less. It does not depend on the shape of the surface, and neither it depends on the area of the surface. Thanks for watching this video lecture. It was short, Just I wanted to get you familiarized with the topic. In the next lecture, we will be taking a detailed description of friction. Thanks for watching.